Hi everyone, we have continually reviewed the definition of the logarithm, and I've presented it here again in the screenshot you see before you. But again, basically, if you have the symbol y equals log base a of x, it means a to the y equals x, and what's inside the logarithm has to be positive. We have properties of logarithms we've already looked at. For example, log base a of 1 is 0 because a to the 0 is 1. Log base a of a is 1 because a to the first is a. Oops, excuse me. Log base a of a to the x is x because a to the x equals x. And this last guy is one of the properties of inverses that I gave you from the composite function definitions of inverses. Now, it's important to note that your laws of logarithms, which could also be called rules of logarithms, are derived from your rules of exponents. So, for example, when you multiplied like bases with in the exponential forms, you added the exponents. The logarithm itself is an exponent. In a moment I'll show you some proofs, but let's suffice it to say that these three rules of exponents are super important in the derivation and therefore your understanding of the laws of logarithms. So therefore, the log of a product is the sum of the logarithms. That's analogous to when you multiply like bases, you add exponents. The log of a quotient is the difference of the logarithms, is analogous to when you divide by like bases, you subtract the exponents. The log of somebody to a power is the power times the logarithm, is analogous to the power to a power rule with the like base. Okay? And this may not be initially just, stand out clear, but your ebook, if I may show you, carefully and clearly demonstrates the proofs of all three of these laws using the rules of exponents. So for example, if you have r equals log base a of u and s equals log base a of w, then you know from the definition of the logarithm that a to the r equals u. We have that here. And a to the s equals w. We have that here. So if you were to multiply a to the r times a to the s, you'd expect in the exponent world to add the exponents. But a to the r equals u, a to the s equals w, so you're multiplying these guys over here. And then if I convert to log form, the exponent is log base a of the result. And going and back substituting, the rule is born. So all three rules are really birthed through the definition of the logarithm and your rules of exponents. Now, if I were you, I would carefully work through Rule 2 and Rule 3 using the examples from the book, and then go back and make sure that you understand that the rules of logs are just as important for us to memorize as the rules of exponents, but they are derived from those rules of exponents. And whether you have log base 10 or whether you have log base e, common log or natural log, the rules are still analogous. Okay? I hope that makes sense to everyone.